Hey guys, today we're going to graph the 15 transmutations in the decay chain of uranium-238. So the first thing I would like for you to do is to know that these are called transmutations. We all know what a mutation is. It's when there's a change in our DNA from a mutagen. This is sort of like that. This is a mutation in chemistry where one element actually becomes another element as it loses protons. So we're going to number the events in our decay chain down the vertical axis. So just go ahead and number these. Now the last one is really not part of the decay chain. It leads to a stable product, so we will not have a nuclear equation for that last transmutation there. The next thing we need to do before we can graph the decay chain is we need to get the number of protons, the atomic number, for each of these elements. And then, of course, these would be the same elements in the product as well. So once we find the atomic number for uranium, we can transpose that to every square that has uranium in it. So if I look at uranium on the periodic table, it is element number 92. Now you have your periodic table as well, so you can double check me on all of these. But every time I see uranium, which is also abbreviated U, I'm going to put a 92. Because I will need that information when I start graphing this in a few minutes. The next one is thorium, which is number 90. All of these should be close together. So 90 for thorium. And every time we see thorium, we will put a 90. And then I have protactinium, which is number 91. I will put a 91 every time I see protactinium. And we're just going to continue this. Radium. So if I can find radium here. Radium is number 88. Radon, Rn, is number 86. Polonium should be close by. Polonium's 84. Lead is 82. Bismuth is 83. And then we've already had polonium one time before, so we'll transpose that. 84. Lead's 82. Bismuth was 83. Lead 82. Polonium 84. And we have all of our information that we need to graph the decay chain of uranium-238. So now, put this paper to the side so that you can refer to it. And I would recommend having a ruler or a piece of paper that I could sort of guide myself down each transmission, each row, so that I don't get confused and get lost. Now your graph paper, which you also have, the top part's been cut off. That just says you rate uranium decay. You can write that in if you'd like. And I'm going to use some colors to help you with this. So alpha decay is going to be an arrow going down. And if you look on Canvas on your standards for this unit, it says one of the things you have to know is that when you have uranium decay, the mass is going to go down by 4, and the atomic number will go down by 2, because alpha is really a helium nucleus. And if you look on your periodic table, helium has a mass of 4 and its atomic number 2. Now beta decay, the mass will stay the same. So I'll use blue for beta. Mass stays the same. And the atomic number is going to go up by 1, and we'll see how that happens when we start writing our equations. So I will color my lines for alpha red and my lines for beta blue. If we look on our decay chain that we have just graphed, in the first decay it says uranium has a mass of 238 and an atomic number of 92. So, and that is alpha decay. I'm going to use a red pen for that. I'm going to go over here to my graph, 238 and 92, and I'm going to put a dot. Now, over a long, long time, 4 billion years or so, that uranium decays, the nucleus comes apart, the protons leave, and the mass decreases, and it changes to thorium-234. So we need to plot 234 on our graph as well, and then draw a line connecting the two. So the mass is 234, the atomic number is 90, and that would be right here. Now if you have a ruler, you can make a straighter line than me. I'm just going to sort of connect those the best I can, making the straightest line possible. And I put an arrow going down to show that the mass did decrease by 4 from 238 to 234, and the atomic number did decrease by 2 like we said it should, because we went from a 92 to a 90. That's our first transmutation in the decay chain of uranium-238. So you can check that off if you would like to help you keep up with where you are in your graph. And then you go down to the next step in the decay chain. Realize that the thorium-234 is already on the graph. All you have to do is plot the decay product. And they call the decay products the daughter material because that's what ends up resulting. So there's a name they use for the decay products called the daughter material. And of course, like you would think, the element you started with is called the parent material. So if you see those two words on a test or information or worksheet, just know the daughter material is what you start with. The parent material is what you start with, and the daughter material is what you end up with in the decay process. So we're going to go to step 2, and we're going to plot protactinium-234, realizing we already have this dot on our graph. And this is a beta decay. So we'll put 234-91, and notice that the mass stays the same in beta. However, the atomic number goes up by 1 because beta is an electron. And we know that electrons have no mass. They're virtually massless, but they do have a charge of -1. So the atomic number is going to go up by 1. And we're going to continue this process. The next step would also be a beta. And I won't bring this over each time. You can look at your sheet sitting beside of you. But we're just going to go straight down and plot these other dots and connect them. So on line 3, we have uranium-234-92. Again, the mass stays the same because it's beta decay, but the atomic number goes up by 1. Okay, then line 4, we have thorium-230. And thorium is number 9. So we will draw a line going down because this is alpha decay. And notice the mass goes down even more. The next several transmutations are going to be alpha. So on line 5 we have radium-226. So we'll put 226. And radium is 88. Okay, and then for line 6 we have radon-222. Line 7, polonium-218. So we're just continuing to decrease in our mass, which is what happens in nuclear decay. And line 8, we have lead-214. Lead is number 82 in the chart. You can make the lines a lot straighter with a ruler. And then after line 8, we have number 9. That's a beta. So now we're on line 9, and the next couple are betas. So bismuth-214, again atomic number is going up by 1. Then we have line 10, which is polonium-214. Mass stays the same. Atomic number goes up by 1. And then we have the rest of these are going to be alpha. We have, let's see, make sure we have a couple more beta here. So we're on line 10, polonium-214, 84. Line 11 would be an alpha, lead-210, 82. So that's going to be right here. And then I said we were done with beta, but we're not. The next two are going to also be beta. We have bismuth-210 and polonium-210. So again, you'll notice the mass stays the same. Atomic number goes up by 1. And the last step in our decay chain is going to be when we make a stable product, which would not be radioactive, and that's lead-206. So now we are done graphing the decay chain for uranium-238. So you should be able to know the difference between alpha and beta decay using this particular decay chain as an example.